Hello and welcome to another Regions Review by Mr. Schweitzer. This one's going to be about earthquake epicenter location. Epicenter is the location on the surface of Earth where an earthquake occurs. In this case, I'm not going to go through the entire thing. That would be a really long video. So I'm just going to talk about Denver, Colorado. So we got Denver, Colorado here. And first off, we've got to figure out if an earthquake actually happened. So we've got a P wave and an S wave, perfect. Later on, the ground would actually start shaking a little bit if we're close enough to the earthquake. We might be able to feel it. But right now, we're going to stick with, like I said, Denver, Colorado. So let's first figure out what our scale is going by here. So I see a 0, I see a 1, I see a 2, I see time. So I'm guessing 1 hour, 2 hour, 3 hour. Wait, what's that? Minutes. Okay, so we're talking minutes here. So we got 0 minutes, 1 minute, 2 minute. Good. So now what does each one of these lines go by? I mean, we could figure out with math because there's 1 minute. 1 minute equals 60 seconds. But we're not going to really do that because I just want to figure out what the scale is. It's nothing crazy. So let's try guess and check 30 seconds. So 0 minutes, 30 seconds, another 30 seconds gives me 1 minute. No, this isn't the 1 minute line. So let's try 15 seconds. 0 minutes, 15 seconds, 30 seconds, 45 seconds. 45 seconds is not equal to 1 minute. So let's try 20 seconds. 0 minutes, 20 seconds, 40 seconds, another 40 seconds will give me, yes, 60 seconds equals 1 minute. 1 minute is right here. Perfect. Okay, so each one of these goes up by 20 seconds. So since I'm right here for Denver, 20 seconds and 40 seconds. So let's see. I like to draw from the top of the peak here, not from the initial shake, I guess. This is really the measurement of the first shake there. So I'm gonna say it's not right between 20 and 40 seconds, but it's pretty close. So you could say, let's start with 2 minutes, right? 2 minutes, because it falls between 2 and 3, so we always take the lower number there. 2 minutes, and you could say 30 seconds, but I'm going to say it's, yeah, we'll stick with 30 seconds. Nothing, we don't want to go too crazy. I could have said like 28 seconds, but we're just going to give a nice round number. Do be as accurate as possible, but don't be crazy trying to figure out what the time is if it's going to waste time. So that's my P wave arrival time. Now I'm going to figure out my S wave arrival time. I come down from here, right? Nice and straight down. I'd say that's about 6 minutes. And yeah, about 30 seconds again. So we've got P wave arrival time of 2 minutes and 30 seconds, S wave arrival time of 6 minutes and 30 seconds. Now we need to find the difference. In this case, you always put the S wave as the first number and then the P wave at the bottom, because the S wave will always be a larger number because it's a later time. So we've got 6 minutes and 30 seconds. I am going to draw my dotted line in. You could even draw a whole line in. So that means I need to do my minutes. I need to do my seconds before I subtract my minutes. 30 minus 30 is 0, 0. Dot, dot, right, because it's time. 6 minus 2 is 4. So that we've got a difference of about 4 minutes, right? All right, good. So let's take a look at this. Sorry, I had to walk away for some scrap paper. Ooh, almost knocked over the iPad. Okay, so we got a difference of 4 minutes. Now, we got to go to this crazy...
Custodian interruption. Can I have a custodian to the main office, please? Custodian to the main
Gotcha,
office.
Bratcher. On my way. No. So we got a difference of 4 minutes. Now you come to this page and you're like, oh God, what do I do? What do I do? If you're really just not sure what to do, in this case, you're gonna do the paper thing on the side here. But if you have a random multiple choice question or short answer question and you don't know what to do, you might as well just do this on the side here. So I've got a difference of 4 minutes. Notice my unit is time here, and it actually goes by the same scale. Every line here is 20 seconds. So I start by putting, right, my paper along the time scale, because that was a time that I figured out. I didn't just figure out a distance. 4 minutes is not a distance. If you ever think 4 minutes is a distance, whew, not good, guys. 4 minutes is time, because time is minutes, and minutes is time. So I put a mark down at 0, right? And in this case, I could put it right at the 4, because we got 4 minutes. Be as accurate as possible for this. If you go off a little bit, like 20 seconds up here, you will probably get the wrong answer. And when I say probably, you'll get the wrong answer. So I'm going to take, this is what I'm working with, right? I got my 2 dots. This is what I call my P wave line. This is what I call my S wave line. We got our P and S waves there. So I'm going to slide this guy up the P wave until this guy reaches the S wave. Try and be smooth about it, but it doesn't really matter how smooth you are. Now, a lot of kids will go up like this, and they'll be like, okay, well, here's where I stop, right? Well, what's wrong with that? It's sideways, right? What you're really saying is that the earthquake was 4,200 kilometers away, but that's not true because these aren't on the line. So you got to keep your paper nice and vertical. Make sure it's parallel with all these lines that are running vertically. So let me see how accurate this is. That's looking pretty good. That's looking real good there. Notice that my dot is an extension of this line here, right? I don't have to like jump over, kind of like some kids stop here and they're like, oh, that's close. Well, I can't jump right onto that line. I need to be right on that, just like that, okay? So I read down, I read down, I read down, I read down. Oh, don't let it slip like that. And then I'm going to hold my pencil here as I move it away. What does each one of these go up by? Well, if you look here, this is between 1 and 2, so let's do a guess and check. 1.1, 1.2, 1.3, 1.4, 1.5. That is not 1.5. Let's try 0.1 more. So 1.2, 1.4, 1.6, 1.8, 2.0. Perfect. So these go by 0.2, each one of these little lines there. Now, what does this little guy mean here? Because we can't say it's one kilometer away, 2 kilometers away. So what I do is I put a 1 there, right? Because 10 to the third. Draw my 1, and this is the amount of zeros I need to follow with that 1. So 10 to the third has 3 zeros after it, right? So I need to multiply 0.2 times 1,000. And any number you get down here, you're going to want to multiply by 1,000. So we got 0.2. Wait. Nope. What was my number at? I totally forgot. Let's find this spot again. Right here. It's not going to be 0.2, thank gosh, because 0.2 is right here. So I'm going to read down. Oh, right, I marked it. About 2.2, 2.4, 2.6, 2.6 there. Let me get that out of there. 2.6 times 1,000 equals 2,600. So my distance from the epicenter, if the P wave reaches me 4 minutes before the S wave does, I will always be 2,600 kilometers away from that earthquake. All right, so now we're here. We've got 2,600 kilometers, and I'm going to go to my map. So I got to remember 2,600 kilometers. Here is my map. Wait, what city am I doing? Denver, Colorado, 2,600 kilometers. Here's Denver, Colorado, this point right here. And now I take my handy-dandy little bullseye compass, and I got this little, right, little squeaky part there. I am going to go down to my scale, put my right, where's that camera? Put my, this is a right angle right there, right here. I am going to put that right angle right at 0, and I'm going to slide either this inner one or this outer one. I like to go with the inner one if I can, because it's just, I like to keep it consistent. And we're going to 2,600. So this one right here is 2,600, and I'm going to point the tip of this red part right at 2,600. I mean, like, right at it. It's got to be just about perfect. Inner, right? I remember that I'm on the inner one. Oh, I forgot which one I'm at. I can go back here. Okay. Inner one points at 2,600. Is that accurate? Yes, that is. Okay, good. So I put my bullseye compass right on the city's dot there. And I take my finger, put it there. And my pencil is going to make a nice circle around. Be careful not to move the red, right? I'm going to keep going around. Ooh, it's kind of jammed. Notice that my circle went right back to where I started. That means I did it right. So we got 2,600. Now, let's say I've got another circle on here, somewhere over here, and it looks something like this, right? And then I've got another circle over here that looks something like this, right? So where am I going to put that? Well, that's a pretty bad example because I've got 1, 2, 3, 4 spots there. There's usually 3 spots. So I'm going to choose the spot that has the tightest packed over here. So this is going to be this side. I'm going to place an X. Boom. Right in the middle of that. X marks the spot, right? Perfect. Okay. Hopefully that helps with the math there. And good luck.